This is a video for EDX Statistics 1. It is the first video in this series and it will cover the mean and variance of a binomial distribution. We will first talk about calculating the mean and variance. Because the binomial distribution is a discrete distribution, we can find the expectation or mean of x by multiplying the individual outcomes by each of its associated probabilities, and the variance by calculating the expectation of x squared minus the mean squared. This slide is showing that process for the binomial distribution with n equal to 12 and p equal to a half. You may notice that the expectation of x is the same as n times p, which is 12 times a half, which is 6, and the variance of x is the same as n times p times 1 minus p, which is 3. Here is another example where n is 20 and p is a quarter. The mean, again, is n times p, 12 times 0.25, which is 5, and the variance is 12 times 0.25 times 0.75, which is 3.75. It can be shown that this is true for all binomial distributions. Note that q is often used to represent 1 minus p. If you want to prove this for yourself, you need to treat the binomial distribution as a standard discrete random variable and use its formula for finding probabilities along with these here. Here is an example of using the mean and variance formulae for the binomial distribution. First of all, E of x, which is np, so in this case 12 times 0.4, which is 4.8. The variance of x is npq, which is 12 times 0.4 times 0.6, which is 2.88. The second thing we're asked to do is to find the most likely value of x. Looking at the possible values close to the mean, it is clear that 5 is the most likely. I've used a probability calculator to find these values, and you will need to know how to get these values from your calculator. Here is an example of using the formulae in reverse. So we know that the mean, np, is equal to 6, and the variance, np 1 minus p, is equal to 4. And we can solve this simultaneously to find n and p. The easiest way to do this is to divide the variance by the mean. This will leave you with 1 minus p is equal to 4 over 6, or 2/3. So we get that p is equal to 1/3, and then substituting that back into the mean will give us that n is equal to 18. That's the end of this video. The next video in this series is looking at the Poisson approximation to the binomial distribution.